Hello everyone. In today's video, I am going to explain the preparation and uses of ammonia. Ammonia is a gas and its chemical formula is NH3. So if you want to make ammonia, we need two raw materials. One is nitrogen and other is hydrogen. So we have to see where do we get these two raw materials from. Let's see first of all where we get nitrogen from. Nitrogen, is present abundantly in the air. So what we can do is that we can obtain nitrogen from air. But how? So we can do the fractional distillation of liquid air. In this process, the air is first liquefied and it is fractionally distilled. That means separation is done on the basis of difference in their boiling points. Okay. Now let's see where we get hydrogen from. The biggest source of hydrogen on earth is water. So we can obtain hydrogen from water, but how we can obtain hydrogen from water? So the process that we use to get hydrogen from water is electrolysis. Electrolysis is actually the process of passing electricity through water. But water is not a very good conductor of electricity. So what we do is that we take water and put a little acid into it. Acid makes it a better conductor of electricity, and then you will pass electricity through it. So what will happen? Here we got the water, and when you pass electricity through it, it is converted into hydrogen gas and oxygen gas. We have to balance writing to here and to here. So we get hydrogen. The advantage of this method is water is renewable. But what is the disadvantage of this method? This method is costly, and costly because of the use of electricity. That is costly. Now let's see the next source of hydrogen. This was the first source of hydrogen. The second source of hydrogen is the cracking of petroleum. Cracking, is a process in which petroleum molecules, the long chain petroleum molecules, which are less useful, they are converted to small, more useful ones. And during this cracking process, hydrogen is also produced. So, for example, we got a compound like C10H22. This is a part of petroleum, and when you crack it, cracking requires high temperature and absence of air in the presence of silicon dioxide and aluminium oxide as catalyst, while we need a high temperature and there has to be the absence of air. So we can get smaller compounds, like compound that we can get is C10H20, and along with we get hydrogen. Now what are the advantages of advantage of this process? This method is a cheap method because in the oil refinery we do cracking to have more petrol. So during the cracking process we get hydrogen as a byproduct. So that's why it's a cheap process. But what is the disadvantage of this method? Disadvantage is that petroleum is non-renewable. So these are the two sources of hydrogen, that is from water and from petroleum. And let's move ahead now and see how we can use nitrogen and hydrogen to make ammonia. So ammonia is prepared by reacting nitrogen and hydrogen by the process known as Haber's process. Haber was a German scientist, and he reacted nitrogen gas with hydrogen gas, and this reaction is a reversible reaction and produced ammonia gas. Remember, nitrogen is a gas, hydrogen is a gas, and ammonia is also a gas. So we are reacting two elements together to make a compound. So let's study the conditions required to make a maximum yield of ammonia. So looking at this reaction, you see that there are 4 moles of the products. 1 mole of nitrogen react with 3 moles of hydrogen to make 2 moles of ammonia. So okay, and this reaction, delta H value, so it's negative delta H, means this reaction is exothermic, and exothermic in the forward direction, and it will be endothermic in the backward direction. So let's see now which are the ideal conditions in which we can get maximum ammonia. So if you look at the temperature, we know that higher temperature always favors the endothermic side. Now, in this case, the endothermic side is backward. So we want to make this reaction to move forward. That means we need low temperature. Low temperature will do what? What is the effect of low temperature? Low temperature will shift the equilibrium towards right side because the right side is exothermic. But what is the problem with the low temperature? The problem with low temperature is that we will have a slow reaction. At lower temperature, particles will move slowly and they will collide less frequently. Hence, reaction will be slow. So, what is the actual condition that we use in the Haber's process is a temperature that is 450 degrees Celsius. Now, let's see the next condition. The next condition that we have is the pressure. In the equilibrium reaction, the reversible reaction, uh, higher pressure always favors the reaction with less moles. So in this case, we got 4 moles here and 2 moles over here. That means if we have a higher pressure, equilibrium will shift towards the right side. So we'll get more ammonia. So it means we will have, in ideal condition, we should have a high pressure. But again, what is the effect of high pressure? Effect of high pressure is the same. Equilibrium move toward right side because there are less moles in the forward direction. But definitely there are problems. High pressure. Look, this reaction that we are carrying out, the Haber's process, it is done in a closed container. Why do we use the closed vessel? Because in the open vessel, there'll be gases and they'll escape out. So we have to use a closed vessel in this case. So in the closed vessel, if we increase pressure, if we keep on increasing pressure, what can happen? Definitely the container, it can explode. So there is a risk of explosion. The second problem that we face in this case is that if you want to prevent the risk of explosion, you need to have a very strong containers. So that will make this process costly. So what are the actual conditions that we use for this process is 200 atmospheric pressure. Now, there are two more conditions that we use in this process. One more condition is that we keep on removing ammonia. Removing ammonia constantly will always shift the equilibrium towards the right side. Okay, but definitely there is no problem with it and nothing actual. So we keep on removing ammonia to shift the equilibrium towards the right side. While the final condition that we have is the use of a catalyst. The effect of catalyst is speeds up the reaction. And how it speeds up? It lowers the activation energy by providing an alternate route to the reaction. So the catalyst that we use is iron. So these are the conditions for the Haber's process to make the maximum yield, but actually we are compromising on the conditions. We are not having a very low temperature so that we can get more ammonia, but we are having a reasonably high temperature so that we can avoid the slow reaction. So we cannot use a temperature more than this because if you have a more than this temperature, we are going to shift the equilibrium more towards the backward side. So there will be less yield. We cannot have a very low temperature because if you keep a very low temperature than this, the reaction become even more slow. So this is an optimum temperature that we are using over here. Again, the pressure, a very high pressure will definitely give you a greater yield of ammonia, but it will be result in the risk of explosion and it becomes costly. And low pressure than this will not give you a reasonable yield. Look at this graph in which the effect of temperature and pressure is shown on the percentage yield of ammonia. So if you see on the x-axis temperature is increasing. So you see in this graph that when the temperature is low, we get the maximum yield. And as we increase the temperature, the yield is decreasing at a constant pressure. This graph is at 400 atmospheric pressure. And you see 400 atmospheric pressure, this graph is at the highest level. It means that at higher pressure, we get greater yield. And at lower pressure, we get less yield. So higher pressure and lower temperature, that gives us the greatest yield. Now let's see what are the uses of ammonia and how do we use it to make fertilizers. Ammonia can be used to make fertilizers. How do we make fertilizers from ammonia? It is by reacting the ammonia gas with different acids. Like we can react ammonia with nitric acid and it will give you what? It will give you ammonium nitrate, that is NH4NO3, and this is a fertilizer, ammonium nitrate. We can make ammonium sulfate by reacting it with sulfuric acid. So we get NH4 twice SO4. It's called as ammonium sulfate. It's also a fertilizer. Then we can react ammonia gas with phosphoric acid H3PO4 to make a fertilizer, that is ammonium phosphate NH3PO4. Let's balance these equations. We need to write 2 here, and for this one we need to write 3 here. So different fertilizers we are making. The next fertilizer that we can make from ammonia is by reacting the ammonia gas with carbon dioxide, and in this reaction we get the fertilizer, that is urea, along with water is produced. Now let's balance this equation. We got 2 here to balance, I think. So this is urea. So we have made different fertilizers from ammonia by reacting with acid, and these fertilizers, they are added into the soil and they increase the fertility of the soil, so we get greater crop yield. Uh, these fertilizers, they are all water soluble, and why they need to be water soluble? So that the plants, they can absorb these nutrients from the soil through water, because water, plants will take up water from their roots, and these dissolved minerals, these dissolved fertilizers, they will also be absorbed by the plants. So now let's see the percentages of nitrogen in different fertilizers. So for example, we have ammonium nitrate, that is NH4NO3. So if you want to find the percentage of nitrogen, you will use the mass of nitrogen, that would be 14 plus 14, 28, and divide it with the molecular mass of this compound, so which is 80, and multiplied by 100. So that will give you the percentage of nitrogen in it, so which is 35%. Let's find percentage of nitrogen in urea. So urea is NH2 twice CO, and the percentage of nitrogen in this, it would be 28, and the molecular mass of urea is 60 times 100. So we'll have a greater percentage of nitrogen in this, so which is 46.6%. So different fertilizers, they provide different percentage of nitrogen, and the greater percentage of nitrogen means the more effective the fertilizer is. Let's discuss an important issue. For example, the soil that you are putting in fertilizer is acidic. So to make the soil neutral, what we use, we add calcium hydroxide into the soil. This is a base and it will neutralize, react with the acid in the soil, and it will neutralize it. So if we add any ammonium fertilizer like NH4NO3, it contains ammonium nitrate. So if we put ammonium nitrate and calcium hydroxide together at the same time in the soil, what will happen? That they will both react together and we get calcium nitrate, CaNO3 twice, along with we get water, and the more important thing is ammonia. So ammonium nitrate, when added to a soil in which already calcium hydroxide is added, we get ammonia. So ammonium nitrate that we have added in the soil, it actually provides nitrogen to the plant, and nitrogen is used to make proteins. So when we add this ammonium nitrate in a soil that already contain calcium hydroxide, they will both react and they will produce ammonia. Ammonia is a gas and it will release out in the air. So what will happen? That the nitrogen content of the fertilizer will decrease. So we should not add these two compounds together in the soil. Now, finally, in this ammonia unit, we have to see that what will happen if we use excess fertilizer in the soil. Fertilizers, they contain nitrates and phosphates. So these nitrates and phosphates, if they are used in excess, what they cause? Actually, from the farmland, these fertilizers, they are leached, they are washed away with the water, and they can reach into the nearby water reservoir. Now what happens over there? These compounds, nitrates and phosphates, they increase the growth of algae. Algae, are green plants, they are present in the water. And what happen? These algae, they cover the water surface, and light do not enter into the water. So as a result, plants will not plants will not do photosynthesis, but they will keep on respiring. So as a result, oxygen level, it drops in the water. Now what next? Plants ultimately die and bacteria decompose them. As a result, oxygen level further drops, and ultimately what happens that animals, they start dying. This process, this whole series of steps which are taking place, collectively called as eutrophication. So this was the unit related to the ammonia, in which we have studied the the sources of nitrogen and hydrogen. Then we have seen how do we make ammonia using the Haber's process, and what are the conditions required for the maximum yield of ammonia. And then how do we use ammonia to make fertilizers? And finally, we have seen the problems associated with the excess use of fertilizers. So hope you have understood all this stuff. Goodbye.